let's begin. Please grab your notebooks and your books for this one. Okay, so again, what we've learned yesterday is about polynomial identities. So the polynomial identities is used to find for, let's say, a missing variables and comparing their coefficients. Basically, class, for example, example number 2, right? So um, this here is similar to the expression on the other side. So what we're trying to say here, class, is that the coefficients of x3 or x cubed here is also equal to the coefficient of x cubed here. That's why we need to simplify this side, and then after that we need to compare the coefficients of each unknowns, okay, to the other side. Okay. Now, when I solved this yesterday, I only simplify the side with the A, B, or C. Okay, so therefore, on this question here, you just need to simplify the right hand side. Okay, right hand side, because um, if I'm going to include this every time I solve one line, it's going to take my time, right? That's why I'm only simplifying the right hand side. So anyway, so let's simplify the right hand side first. Okay, so you need to remove the brackets, right? So you multiply this, and then that's how I got this. X cubed minus x squared plus ax, and then negative 1 times negative x times a. And then that's how I got this. Negative x squared plus x minus a, and then you bring down b. Okay, and what's after that? Now, after this, you need to combine like terms. So since x cubed doesn't have any pair, so we bring down x cubed, and then we simplify negative x cubed and x squared, and another negative x squared. That's how we got this negative 2x squared, right? And then let's combine the x terms. So ax and then x. But we cannot combine this, right? Because you cannot add a and number 1. So therefore, we write it like this, ax plus x, right? And then since a and b doesn't have any x terms, we just bring down both of them. And that means that this 2 here is your constant term, okay? All right, now, so once we're here, we still need to factorize this. Okay, we need to factorize this. We should combine these two by factorization. So we bring down all of this. Okay, then how do we factorize this? Simply, your common term or your common factor is x, right? And then you divide each term by x, and that's how you get a plus 1, right? So it's now a plus 1 times x. So this is your simplified simplified work for this side. And what's next after that? So once we've done simplifying this, what's next? Okay. Again, this is done by comparing the coefficients. So when you compare the coefficients, you're basically just comparing the number or the expression in front of x. For example, now we are looking for a, right? A and b, because those are the two unknowns on this question, right? So we have a plus 1 x. Now, if you're looking for a's, since x is the variable for this expression, we need to compare this with this, because it says here that x cubed x cubed minus 2x squared plus 4x plus 3 is similar to this side also. Okay, so they're similar to one another. So that means that they have, we can compare coefficients on this one. All right. So again, if we're looking for a plus 1, and then the variable is x, we look here, and then we look at the variable x as well, or the x terms. So what is the x term here? So this is 4x, right? So we compare this and this one, okay? So is that clear? Any questions, class, on how I compare this and these two? What's your indicator that they are similar to one another? Of course, it's the x term. Since this is x, this is equal to this also. Okay, that's how you look for the similar variable. Okay, you compare their coefficients with the similar variable. Now, maybe you're asking, is this can I compare x to x squared? Of course not, because these are two different terms, right? You cannot compare this. Even so, x cubed, I can compare x with that. They should be the same, right? So x and x. That's how I got this. Okay. So since I'm looking for a, so it's a plus 1 and then this one. Okay. And now look here. So just the coefficients, right? So just the coefficients. You remove the x. Okay. So you bring down a plus 1 and 4, and then that's how you get a is equal to 3. Okay. So that's a already. Now, how do we get b? So since b is connected to negative a, so we need to use this expression, and then we compare this to the constant term, which is 3. That's how I got negative a plus b equals 3. And then solving for b, so we know that a is 3, so it's negative 3. So b is equal to 6. All right? B is equal to 6. Okay. And then okay, that's your answer for number 2. Now let's have another example. All right, number 6. Okay, so for number 6, we have x squared plus x plus a is similar to x plus a times x minus 1 plus b. So we're looking for the values of a and b. However, we have a here, and it's all right. It's okay. So we just maintain a here. What we need to simplify is the right side, or the right hand side. So how do we simplify this? So again, it's the right hand side. So removing the brackets, so x times this, I got x squared minus x, a times negative 1, I got ax minus a, and then bring down b. All right, what's next after this? You need to combine like terms. So x squared is alone, so we bring down x squared, and then we have negative x plus ax. So how can we combine this? So again, we can combine this by factorizing this expression. So it becomes minus 1 minus a times x. So your common factor is x, right? And then divide each term by x. So negative x divided by x is 1. And then positive ax divided by negative x. So it's negative a. Okay, so that's what happened here. And then next, so since negative a plus b doesn't have any x terms, this is All right, I think my internet got disconnected. Okay. So as I was saying a while ago, I have written this here in another way. So say I have done simplifying this. Okay. Um, so let's compare this and this one. Okay. So let's compare them side by side. Okay. So if you're looking for a, that means that since this is in terms of x, this is comparable to this one, right? So that means that their coefficients are also equal, right? So that's how I got this. So again, this is equal to this one, okay? And then comparing their coefficients, so you bring down negative 1 minus a, and then what is the coefficient of x? It is 1, right? That's why this is 1. Okay, and then solving for a, so a is equal to 2. All right, how about letter b, or the value of b? So to get the value of b, you start with this. So negative a plus b. So use this, and this is, you can compare this with this one because they are both constants. Okay, so that's how I got this. So negative a plus b is similar to a. So therefore, negative a plus b is equal to a. So if a is 2, so you have negative 2 here and 2. So therefore, b is equal to 4. Okay, so that's how you compare the coefficients. Okay, before, like yesterday, I wasn't writing it like this because I don't want to repeat writing this and this and this like 3 times, 4 times, 5 times. That's why I'm just writing, or I'm just simplifying the right hand side or even the left hand side. I'm just simplifying one side and I'm just comparing it with this. Okay, but you can also write it this way. Okay, if you can, if it will help you, you can write it like this. Okay, so you'll see it clearly, like x is equal to this, so therefore their coefficients are also equal. So same with this and this, right? So let's have our last example from yesterday. This was your homework, right? Okay, so we're given 6x cubed minus 5x squared minus 3x plus 2. And then we need to find the value of a, b, and c. This, and this, right? So basically, class, we need to simplify this side, right? So let's remove the brackets right away. So x times this, times this, times this, it will give you ax cubed plus bx squared plus cx, right? And then next is negative 1 times this, and then that one. So you'll get negative ax squared minus bx minus c. Okay, so that's it. We have removed the bracket. So what is next for that? Now, what's next is we need to combine like terms. So since x cubed is just alone, we just bring down x cubed, right? And then we combine x squared and minus ax squared. So when you combine this, of course, you cannot just combine a and b, right? So this is how we combine this. Ax squared plus bx squared. And then, of course, the x terms, we have cx and then negative bx. So I wrote them together like this. So minus bx plus ck, and then lastly, we have minus c, which is your constant term because it doesn't have any x or variables with it. Okay. So what is next after this? So again, we need to simplify this, and we need only one x squared terms and then x terms. So to simplify this, we need to factorize this. We need to combine them by factorization. So what we did here is you look for the common factor, which is x squared, and then you put it behind, and then you divide each term by x squared. So basically, you'll get a minus b. Okay, maybe you're asking, why is it a minus b? It is plus here, right? It's because of the bracket. And this is plus or positive divided by a negative x squared. That's why this is minus b. Okay, now let's go with the x terms. Um, So what is your common term? Your common term is, or your common factor is x, okay? Is x or negative x. So you divide each term by x, so this is b, and then minus c. So again, plus divided by negative is negative c. And then you bring down c. Okay, so after that, we have simplified completely, or completely simplified the expression, this one. Okay, so we can compare this and this now, right? Okay, again, let me change how I write this. Okay, so let me just move it right here, and then, okay, might help you. Okay, okay, so you can write them side by side like this. All right, so you see it now. Okay, so if you're solving for a, since a is connected to x cubed, that means that this x cubed is similar to this x cubed, right? They're similar, so their coefficients are equal, right? So therefore, look, that's how I got this, okay? And so therefore, a is equal to 6, okay? Of course, x cubed gets canceled out, right? Okay, so a is equal to 6. Okay, so we're done with a, right? How about b? So we can use this one to find the value of b, okay? So again, how can we compare this to this expression here? Of course, we look for the x squared term. So where's that? So this is equal to this, right? So that's how I got this is equal to minus 5x squared, this one, okay? So negative a minus b x squared is similar to negative 5x squared. And then remove the x squared terms. So you're left with negative a minus b equals negative 5. So since a is 6, so you just insert 6 there. And then removing the bracket, you'll get negative 6 plus b equals negative 5. So therefore, b is equal to 1. Okay, and then lastly, so we need to find for the value of c. So c is here, so this is constant since it doesn't have x or even x squared, right? So this is similar to this one, okay? So they're similar to one another. That's how I got negative c is equal or similar to 2. So basically, c is equal to 2. Sorry, this is supposed to be negative 2. Okay, negative 2. All right, so that's how we find a, b, and c on this one. Okay, so yeah, that's it. Do you have any questions, guys, for the examples that we have discussed? Hmm? Okay, no question, class. Okay, so again, class, um, this is your workings. Again, you don't have to write this again and again and again. Okay, when you answer this, you just get the simplified form of this, and then you just compare it from here. Okay, but if this one will work for you, so you can clearly see the common terms or the similar terms, you can do so. Okay, like this. All right. All right, and anyway, that's it for polynomial identity. So for today, we're going to learn what is remainder and factor theorem. So when you were in primary, when you divide numbers, sometimes you'll get remainder, right? So for example, when you divide 5 and 2, right? Of course, there is a remainder here, right? So of course, this is 2, and then this is times, then you get 1. What is your remainder, right? Do you guys still remember this when you were in P4 or P5? Okay, so this is how you divide numbers, right? But in algebra, we can also divide polynomials. Okay, look at this example here. Okay, looks complicated, right? But the process is just repeating and repeating until you get the remainder. Okay, let's have this one first, and then from here I'll discuss what is the remainder. basically, we are dividing 2x to the power of 4 minus 3x cubed plus x squared plus 1 by x minus 2. That's why this is inside this one, and then this is your divisor, right? So how do we divide polynomials? Okay, so basically, you divide this by x. All right. So 2x raised to 4, or to the power of 4, divided by x. What will you get? So it's 2x cubed. Okay, cube. Again, 2x raised to 4, or to the fourth power, divided by x. Of course, you will get 2x cubed, right? And then that's how I got this. Okay, this is your quotient. Okay, this is your answer. So that's how I got this. Now, why did I write it here and not here? Huh? It's because I'm aligning all similar terms. See, it's similar. This is 3x cubed, right? So I'm putting it above the x cubed terms as well. So I'm aligning them according to their uh, terms. Okay, this is x cubed, so I'm aligning them. Okay, so don't write it here because they're not the same, obviously, right? All right. Anyway, what's next? So once I got this, what's next for me? Next is to multiply this by x minus 2, right? So multiplying this by x minus 2, you'll get 2x to the power of 4, 4x. Okay, 4x cubed, all right? So minus 4x cubed. So 2x cubed divided times negative 2. That is minus 4x cubed. And what is next after that? Now you see the red signs because the next step is to get the opposite sign because we are going to subtract, right? So to subtract this, you need to change the sign of this one. So this one becomes minus, this one becomes plus. Okay, so basically this is 0. This is gone. And then when you simplify this, so this is negative 3x cubed plus 4x cubed. So your answer is x cubed. Okay. All right. And then what's next? So we repeat the process again. So x cubed divided by x. What do you get? So you get x squared, right? And then you repeat the process. X squared times x minus 2. You'll get this. Oh, sorry. You'll get this one, right? So x cubed minus 2x squared, right? And then you repeat the process. You change the sign of the subtrahend. You change the sign of this. So it becomes negative, and then this one becomes positive. So this is 0, right? And then this is what? This is 3x squared. And then you repeat the process. 3x squared divided by x. Obviously, you'll get 3x, right? 3x. And then take note, class, that in my question, I don't have x terms, right? I do not have x terms here. I don't have just x. So what I did here, I put here a placeholder for x. I put plus 0x. Okay, so this is just a placeholder, just to leave an empty space. Sorry, empty space here. You can basically leave an empty space here. Okay, but for some, it will help them if we have plus 0x here. Okay, but you can just leave that empty because you cannot align this with 1 because these are two different terms, right? And of course 3x you cannot align it with x squared because again this is different terms. That's why this is just a placeholder for x. All right, anyway, so once we have 3x, we repeat the process, right? And then we get this. So 3x squared minus 6x, and then we change the sign. Becomes negative, becomes plus a plus. So this is 0. So what is the sum of this? So this is equal to 6x, right? And then plus 1. We bring down that expression. So 6x plus 1 divided by, or simply 6x divided by x, right? So you get 6, right? Again, 6x divided by x, you get 6 because x gets cancelled out. So 6 times this, you'll get negative 6x minus 12. And then for you to make this 0, you need to change the sign of the subtrahend. So this becomes minus, this becomes plus. So this is 0, and this is equal to 13. And that's your remainder. All right. Now, class, as you have seen, the process is tedious, right? It's a bit, not a bit long, it's long and it's a bit confusing, right? Now, for the remainder theorem, what we're looking for here, what we're looking for is just the remainder. So how can we get the remainder? By dividing this 2 and then getting 13 as your remainder. Is there a shorter way for us to get the remainder right away without doing this division of polynomials? Yes, of course, there is a way on how we can get the remainder of this division here. Okay, so you don't have to do this step every now and then. So that is where the remainder theorem comes in. Okay, so so we can find the remainder of a division of a polynomial by just applying what the the topic of functions. Do you guys still remember functions? Hmm? Functions. Okay. So what we're going to do here, class, is okay. So I have another slide here. Yeah. So you guys still remember functions, right? Okay. So instead of doing this, we are just going to use functions. Okay. So you see this. You see x minus 2. This is the divisor, right? So instead of x minus 2, it becomes f of 2. Okay, f of 2. So it's now f of 2. And then f of 2 will now be equal to this. And then you will get the remainder um, of that process. Okay, so how does it work? Okay, so again, the remainder is equal to f of 2. Okay, if it's x minus 2, it's f of 2. Listen, class. Again, if it's x minus 2, that is f of 2. But what if it's x plus 2? So that is f of negative 2. You see the difference? Okay. Because how did I get 2 and negative 2? Simply x minus 2 equals 0. So x is equal to 2. So therefore, it's f of 2. Okay. So let's just insert the function of 2 into this polynomial. And that's how we get our remainder. Okay. So f of 2 is equal to 2x to the power of 4 minus 3x cubed plus x squared plus 1. So you can get the remainder by just doing this, class. And then what's after this? You just substitute x with the function 2. Okay? X here becomes 2, 2, and 2. Alright? And then you can just use your calculator with this, and then you will get 13 as your remainder. So simple as that, class. So you don't have to do this long division method here. If we need to find the remainder, we just use the remainder theorem. Okay. All right. So let's have maybe 3 more examples similar to this one. Okay. All right. Now let's have example number 2. Let's find the remainder when 4x to the power of 3 minus 5x plus 1 is divided by x minus 2, x plus 3, and 2x minus 1. Okay. So for letter A, x minus 2. What is your function here if it's x minus 2? Again, your function here is f of 2, just like this one. Okay, this one. So therefore, for us to find the remainder, we just use the function f of 2 is equal to the expression 4x cubed minus 5x plus 1. Okay, is that clear? And then what do we do next? So we just substitute x with the value of the function, which is 2. So therefore, it becomes 4 times 2 cubed minus 5 times 2 plus 1. So using your calculators, simplifying this, you'll get 23 as your answer. So that means that the remainder for letter A is 23. How about letter B? What if it's x plus 3? What will be your function? Again, the remainder negative. Okay, again, negative. So that means f of negative 3 is equal to this expression. Okay, and then what do we do next? We substitute the x values with negative 3. So we'll have this one. So therefore, after you have simplified this, the remainder is equal to negative 92. Okay, that's the remainder is equal to negative 92. And then last example, what if it's 2x minus 1? What will be your function? Your function, if it's if it's 2x minus 1 is f of 1 half. All right, f of 1 half. But how did we get f of 1 half? Maybe you're wondering, how did I get f of negative 3 and then f of 2? It's here. So I have asked myself, okay? So you might be also asking the same way, in the same question, okay? How did I get f of 2, f of negative 3, and f of 1 half? Okay, so this is the process. So you just make this equal to 0. So x is 2, therefore it's f of 2. This one for letter B is x is negative 3, therefore it's f of negative 3. For letter C, since this is 2x minus 1, when you simplify this, when you solve for x is equal to 1 half, right? So that's how I got f of 1 half, all right? But class, you don't have to show this method because I think you guys can mentally do that, right? Okay, so anyway, for letter C, so it's to get the remainder, you need to use the function of f of 1 half. So f of 1 half is equal to the expression 4x cubed minus 5x plus 1. And then x and x becomes 1 half. So therefore, when you simplify this, you'll get negative 1 as your remainder. Okay, so that's it. Do you guys have any questions on how to find the remainder when you divide expressions? Answers now for number 1A. Again, this expression is divided by x plus 1. So meaning that your function is f of negative 1, right? F of negative 1. Again, where did I get f of negative 1? You make x plus 1 equal to 0. So if it's x is equal, x plus 1 equals 0. So therefore, x is equal to negative 1. And this is your function, okay? F of negative 1. So therefore, to get the remainder of this question, f of negative 1 is equal to the expression, okay? So what happens to the x terms? So the x's becomes, or the x terms become negative 1s, right? So I have negative 1 here until here, okay? And then when you simplify this, you can just use your calculator class in simplifying this one. So you'll get 6 as your answer for letter A. All right, did you also get the same answer, class, for letter A? 6. Answer is 6, okay? Now, how about letter C? Now, for letter C, this is the question. So 3 times x plus 4 squared minus 1 minus x cubed is divided by x. So what is your function if it's x? Huh? It's only x. Again, make x equal to 0, right? So therefore, basically, x is equal to 0. So your function for letter C is f of 0. And that's what I did for letter C. Okay? Your function is f of 0. Why is it f of 0? Because this is just x. If you equate this by 0, basically that's it, right? So that's why your function is f of 0, right? So meaning to get the remainder for letter C, f of 0 is equal to 3 times x plus 4 squared times 1 minus x cubed. And then, of course, you basically substitute x and x with 0 and 0. And then you simplify this, you'll get 47 as your answer. Okay, any question, class, for letter C? Okay, none? Okay, did we get the same answer for 1A and C? Okay. All right. I hope we got the correct answer, and I want to see your workings for A and C. All right. Now, I'll add this example, letter D. Now, for letter D, this is your expression, right? Divided by 2x plus 1. Now, if your divisor is 2x plus 1, what will be your function? So your function for this will be what? For letter D. So 2x plus 1 equals 0, right? So therefore, x is equal to negative 1/2. So therefore, your function is negative 1/2. Okay? And that's my answer for letter D. So your function is negative 1/2 because of 2x plus 1. All right? So to get the remainder of letter D, we are going to use f of negative 1/2. Right? So x here and then x here becomes 1/2. 1/2. Right? So here. Okay, so for this one, class, I highly suggest that type this term per term. Okay, so this one first in your calculators to avoid, to avoid wrong answers. Okay, so this one first in your calculator, and then you'll get negative 8. And then for the next term, you type this inside your calculator, and then you'll get positive 6. And then, of course, you just bring down minus 10. So therefore, your answer for letter D is negative 12. All right. Do you guys have any questions, class, for letter D? Okay, none? No questions for letter D? Okay, so that is, yeah, that's okay. That's your first classwork for this chapter, this part of the chapter. Okay, and then next, let's have some word problems. Okay, with the remainder and factor theorem. Okay, so let's have example number 3. Right. So this is on page. What page is this? All right, so page 87. Okay, but you can just look here. Okay, so on page 87, let's have one example there. Let's have a word problem. So this is different from the questions from number 1. So the questions from number 1, you just need to show and get the remainder, right? For number 3, it's totally different. Okay, so let's have number 3. Now, the expression 4x squared minus px plus 7 leaves a remainder of negative 2 when divided by x minus 3. Question: find the value of p. So how are we going to solve this kind of question? Now, first things first, let's break down the sentence. Okay, so this is basically your expression, right? Now, it says here it leaves a remainder of negative 2. So therefore, your r is already equal to negative 2. Okay, negative 2. Sorry, negative 2. Okay, and then it says here that you'll get negative 2 when you divide it by x minus 3. So therefore, your function is f of 3, right? Now, look here closer, class, right, on this part. So the function is equal to the remainder, right? But on this question here, we already know the remainder is negative 2, right? So r is already negative 2. So we are here now. So how can we solve for p? If that's the case, so what f of 3 is equal to negative 2. So with that, we need to use this expression and then plug in f of 3 inside the value of x. Okay, so that's why, look here, class. I okay, I wrote 4x squared minus px plus 7 again. Okay? But the point here is that to solve for p, you need to apply f of 3 on this expression. What I mean by that is you need to substitute the value of 3 to this x terms. Okay, so therefore this x squared here becomes 3 squared, and then this negative px becomes negative 3p. All right, do you guys have any question? Okay, and the negative 2 doesn't change at all. Okay, until to the last one. Okay, so this is now your expression or equation. All right, do you guys have any question? So again, f of 3, meaning using the same expression, you plug in 3 on the x terms. Okay, so that's how I got this. And then equals negative 2. And then from here, you simplify this, you'll get 36 minus 3p plus 7 equals negative 2. So bring down negative 3p. So 36 plus 7 is what? 43, right? And then when you transpose 43 to this side, it becomes minus 43, giving you negative 45. Okay, so therefore the value of p is equal to 15. All right, so that's it for example number 3. Okay, do you guys have any question on example number 3? All right, last example for today. Let's have example number 4. Okay, now example number 4. This one is trickier than the first example because here you have one expression, but you use two functions to divide this expression, giving yourself two values for your remainder, or two remainders, right? So basically, class, you divided this twice by x minus 2 and x plus 1, right? Okay, but let me read the question first. Given that the expression 2x cubed plus ax squared plus bx plus c leaves the same remainder when divided by x minus 2 and x plus 1, prove that a plus b is equal to negative 6. All right, so how are we going to answer this? Okay, so let me just make this one quick because it's already 2:25. Okay, so basically, class, you have two functions here, right? Because you divided this twice by two different functions. So your first function is f of 2, and then the second one is f of negative 1. Okay, so what do we need to do? Now, why did I write it like this? It's because they are equal to one another. So the remainder of this is equal to the remainder of this. That's why f of 2 is equal to f of negative 1. Okay? So how are we going to write that? So using the same expression on both functions. Okay? So we need to use it twice on both sides. But then, of course, since you have different functions, you have two different numbers to solve, right? So here, on the left side, you change x by 2, right? And then on the right side, your x becomes negative 1, right? So that's what happens, okay? And again, they're still equal to one another, okay? So basically, simplify everything here. So you'll get 16, and this is 4a. Obviously, this is 2b, and then this is c. And then when you simplify this, you'll get negative 2. This one, you'll get positive a. Then this one, you'll get negative b, and you bring down c. So, okay. So we're here now. So what's next? Okay. So what's next after this? So what I'm going to do here is to transpose all variables on the left side and then all constants to the other side. Basically, A, B, C on the left and then numbers on the other side, because this is the format that you want to see. You need to prove that A plus B is equal to negative 6, right? So this is what we're going for. So once you're done transposing all variables and constants to the correct sides, you now simplify this. When you simplify this, you'll get 3a plus 3b. Since c minus c, that's equal to 0, so that's gone. And then this is negative 18, obviously, right? Okay. And then for you to get this, a plus b is equal to -6, you just need to divide everything by 3. And then that's how you get your answer.